Today what we're doing is we're going to take what happens on the unit circle and we are going to convert it into the graphs that we're used to having, where we have an X and a Y, and we let the X represent time, or in this case, the X represents theta, with how many revolutions we're doing around the unit circle. So we're going to discover both of these graphs and where they come from, and then we're going to look at some transformations from them from there. So we're going to start with the graph f of x equals sine of x. And again, in this case, the x, the first thing that I'm missing is theta, right? It's an angle measure. So when we first learn how to graph things, we typically just make a table of values and we make up some x's and we figure out what their y value should be. So let's think about what are some x's, angle measures, that we would like to plug in to sine. Well, I would really like picking values that are on the unit circle because I can identify those values quickly. So, and we're going to be in radians. X is in radians. So we could plug in 0 radians. We could plug in pi over 6, pi over 4, pi over 3, pi over 2. Okay, so what is sine of 0? This is the point where I don't like to have to explain this part anymore, but since we just had the test yesterday, let's go through it. Sine of 0 means I rotate nowhere. That puts me right here. If I'm here, this is the ordered pair 1, 0. Sine is the y value. So if I rotate nowhere, the y value is 0. So f of x is 0. Okay, what about if I rotate pi over 6? Pi over 6 puts me in the first quadrant with a reference angle of 30. Sine is the opposite over the hypotenuse. So if I rotate pi over 6, I get 1/2. You following what I'm doing? Okay, what about pi over 4? What is sine of pi over 4? It's radical 2 over 2. And you know where I got that from. Sine of pi over 3 would be radical 3 over 2. And then what about sine of pi? Over 2, sorry. Sine of pi over 2 would rotate me up here. This would be 0, 1. And that's the y value. So I go all the way from 1. So really, between 0 and pi over 2, I rotated I rotated 1/4 of a full revolution, right? That's 1/4, and here's the next quarter, and the next one, and the next one. Well, what happened in this 1/4? We went from 0 to pi over 2 on the x-axis, and we went from 0 to 1 on the f of x, or the y-axis. So, because this is only the first quarter of the unit circle, we're going to make that graph happen between This is 0, right, the origin. And this is the first quarter of my graph. So I'm going to make this x value here be pi over 2. And I'm going to make the y values, it goes up to 1. Does it ever get higher than 1? No, because what's fixing to start happening? These y values, remember, sine is the y value. These y values are fixing to start going back down until the y value becomes 0 again. Now follow that rotation around the unit circle. And so we start here at 0, 0, and then at pi over 6. Well, let's just do the pi over 4 one. Pi over 4 is halfway between these, right? Halfway between 0 and pi over 2. So that's pi over 4. What is radical 2 over 2? Like, what number is that? That's about 0. You can use your calculator. Radical 2 over 2 is 717. Okay, I think, or maybe 707. Somebody. 707. So it's about 0.71. So when I get halfway there, I'm more than halfway up. Do you follow that? Because halfway would be 0.5. But I'm at 0.7. So it grows very quickly initially, right? Pi over 6 is somewhere here, and I'm already halfway up that quick. So then what's happening? Well, the rate of change is slowing, right? It's starting to level off. And then radical 3 over 2, this is about 0.8. So you see it's not growing as much. And then at pi over 2, I should get all the way up to 1. So if the rates of change are slowing, what can we say about this graph? It is concave down. Hopefully you see that. I'm trying to draw it well, but my graph's a disaster. And then we talked about these values are just going to repeat themselves, right? Just go in the other direction. So then I'm going to start heading back down until I get to, this would be pi. Okay. Yep, we'll see you. What would I get here? What is sine of pi? Well, that would rotate me here. Sine is the y value. The y value is 0. So once I get to pi, this is back to 0. So I've got a new x intercept. And so we're concave down. But then at some point, it's going to switch back to my next axis is 3 pi over 2. What's the y value here at 3 pi over 2? It's at negative 1. And so the graph decreases, decreases, decreases until it hits negative 1 right here. And then my next rotation gets me back to 2 pi. Well, what is sine of 2 pi? We're back where I started, right? I'm back to 0. Is this the end of the x-axis? Like rotating from 0 to 2 pi. Could I rotate any more if I wanted to? Could I rotate 3 pi or 4 pi or 5 pi? What would happen if I extended this graph out? What do y'all think it would look like? Speed that over and over and over and over and over. Okay? This is what's called a sinusoidal graph. Right? Where it repeats the same thing over and over. They're also called periodic because they repeat themselves on a specified period. Okay? We could extend this graph going the other direction. Right? If I go negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Can you guys extend this pattern? Where would this go next? If I went to negative pi over 2, this graph should go down still, right? One of the things that I've learned is I think it's easy to extend the pattern, and then I see my students try to do it, and they can't figure out where to go next. We've got to go all the way down to negative 1, and now we've got to start going back up. So we're going to go back up through 0, and then it's got to keep climbing all the way to 1, and then we're back down. If I rotate negative 2 pi, that means I'm back where I started, right? Sine starts at 0. And you see how I wasn't super exact with the y values in between? Like I showed you where you could find the y values, right? But I'm not super exact with those being in the correct spot. But this point being at 0, at 1, at 0, at negative 1, and at 0, those are very exact. You need to make sure you're at those points because those are the critical points. You guys remember learning critical points with our parent functions in 112. Like the square root of 2, the square root of x, we had 0, 0, 1, 1, 4, 2, 9, 3. For x squared, we had those points, negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. The same way, a sine graph here, it has 5 critical points that you need to have memorized. So this is for sine of an angle theta. You need to know it goes through 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, 2 pi 0. Again, I'm going to reference back to these as we keep building these graphs. These are the 5 critical points. And again, going back to the unit circle, do you know where these points come from? Like, just rotating to an axis. And I'm looking for sine. Sine is the y value at that axis. Questions here. And just to show you where in your guided notes, that first graph they have here for sine, you kind of see they kind of have the same thing we do. They're just a little bit more particular with where their points are because they had a little bit better tools than we had. They discovered it the same way. Plug in 0, pi over 6, pi over 4, pi over 3, pi over 2. But then they kept going. So what would be the next rotation? 2 pi over 3. You can see how it's just starting back over. 3 pi over 4, we're going down. 5 pi over 6, we're at a half. And then at pi, we're back to 0. And then we have to complete that on the negative side in the third and fourth quadrants as well. So that's a sinusoidal graph. So a cosine graph looks very similar to a sine graph because think about what's happening as you loop through. Think about going around the circle. Sine was the y values. The y values start at 0. The y values go up. They go down to 0. Then they go negative. Then the y value comes back to 0. And then we go again up to 1. Back to 0. Down to negative 1 to 0. Over and over and over. Well, cosine is the x value. So if I start here, where does the cosine graph begin? What is the x value right here? 1. So cosine starts at 1. And then cosine's going to go to 0. Cosine then goes to negative 1 right on the left side. And then cosine's back to 0. And again, 1, 0, negative 1, 0. So it's the same type of graph, just starting from a different position as I go around the unit circle. So I'm going to list my 5 critical points for cosine. So again, my x represents theta. And so we're going to look at what happens when I rotate to an axis. I don't care so much about all those in-between points anymore because you kind of know what it's going to do between. You kind of can follow. So if I rotate nowhere, cosine of 0 was 1. Everybody's good where that's coming from? Let me write the function. F of x equals cosine of x. If I rotate pi over 2, I'm at 0. Pi is at -1. 3 pi over 2 is 0. 2 pi is 1. It's my x values as I'm rotating around. Again, I'm at 0, 1. Beginning. Pi over 2, 0. Pi, I'm down to -1. 3 pi over 2, back to 0. And then 2 pi up to 1. And so if I graph my known points here, I'm not good at drawing these. All right? And just like with a sine graph, does it stop here? Can I only rotate 2 pi? But I can keep going. What would the graph do from here if I extended it out? What would be the next thing the graph would do? Start going back down until it met 0. Then it would keep going down to -1. Back up to 0, back up to 1. All right? So let's extend the graph to the left. See if you guys can do it without me helping. Extend to the left. What should the graph look like over there? Again, it may be simple to you, but I don't know. So hopefully over here you extended, you went through the x-axis here, bottomed out at -1 here, back up to 0 here, and then back up to 1 here. Questions? At the very bottom of your guided notes, you see where it asks for the 5 critical points of each one. Can you write the 5 critical points for sine and cosine? Eventually, you're going to have them memorized, right? You may not have them memorized yet, but if you don't memorize them, do you know how to discover them? By rotating along the unit circle to each of the axes. Sine is the y value, cosine is the x value. Let me just show you all that again. Or do you understand that? We're real quiet, so I don't know what that means. That we have drawn. I kind of have talked about it already, but they talk about both of these being periodic functions. And so in both graphs, the shape of the graph repeats after 2 pi. Which means the functions are periodic with a period of 2 pi. So this is going to be very important, is identifying the period of each of these trig functions. So if you look at these, could you know which one is sine and cosine just by looking at these two graphs if they weren't labeled? How could we figure out which one's which? Where they begin. Where they begin. This one goes through the origin. Sine starts at 0, 0. Cosine starts at 0, 1. Okay? So this is a sine wave without any transformations. This is a cosine wave without any transformations. Sine goes through the origin. Cosine starts at 0, 1. So looking here, if I start here, when they talk about the period being 2 pi, basically, how long does it take before this graph repeats itself? Does it do the same thing again? So we start here, we go up, we go down. Does it repeat that pattern again? Does it go up and then down? No. So that's not finished a period. We went up, we went down, we go down, we go up. And what's it do from here? It does it again. We go up, we go down, we go down, we go up. This pattern completes one full revolution, one full cycle after 2 pi. So its period is 2 pi. People typically struggle with that for sine, but they don't struggle as much for cosine. It's easier to see on cosine because it starts at the top, right? So how long does it take before we get back to the top? 2 pi. The difference is this one starts in the middle, right? But it meets the middle again before it gets to its full cycle.
Is it always going to meet the middle again? Is it always going to meet in the middle before it?
Yeah, before it finishes. Yeah. Even with, like, if I started here with cosine, if I started in the middle, from here to here is not a full cycle. You have to go from here to here. And so this would be from negative pi over 2 to 3 pi over 2, which is a distance of 2 pi, right? One full revolution, one full cycle. That means that's the period. Period. How long does it take before it repeats itself? Okay. Let's read those characteristics. This is true for both sine and cosine. True for sine and cosine. They are periodic. Their period is 2 pi. That means it takes 2 pi before it repeats itself. The domain is the list of all possible x values. What did the x's represent here? They represented rotations around the unit circle, theta. So how much can I rotate around the unit circle? Well, I can go in the negative direction as much as I want. I can go in the positive direction as much as I want. So the domain is negative infinity to positive infinity. The range. Those are my y values. So think about what's the highest those graphs got? 1. The lowest, negative 1. Inclusive, so it's in brackets. And remember, sine goes through the origin, and so it is symmetric about the origin. It's odd. Cosine does not go through the origin. It goes through 0, 1, and because of that, it is an even function. Those last two, I have not, well, we'll use it a little bit, but they're not as important as the top two in those points they're making. A sine parent function and a cosine parent function. Just like we have an absolute value parent function. Just like we have an x squared. Just like we have an x cubed. And you know what those graphs look like? You have to know what a sine and a cosine graph looks like before any transformations occur. That's their parent function. It's what we just got done drawing. But just like how with the other functions, we can stretch them, we can compress them, we can shift them left or right, we can shift them up or down, we can reflect them. All of those things, same things can happen with a sine, cosine, and tangent. Or, right now, sorry, sine and cosine graph. Okay? Just stay with sine and cosine. They just have different names. When we shifted a graph up or down, we called that a vertical shift. That's the same thing. Thank goodness. So going up or down is still a vertical shift. When we shift left or right, we call those a horizontal shift. Here, it's called a phase shift. So phase shift is the same type thing as a horizontal shift. We had vertical stretches and compressions, right? We stretched graphs, shrunk graphs. Here, we call that changes to the amplitude. Amplitude is like a vertical stretch or compression. How does that relate? You guys, have you heard the word amplitude before? Talking about what? Probably sound and sound waves. So all of these are waves, sine waves, cosine waves. They're like sine waves. And if we stretch those waves, we are changing the amplitude. Vertical stretch or a vertical compression. And then the last one is kind of unique to periodic functions, because every other function that you've had a parent function for so far, they didn't repeat themselves, right? Like an absolute value function doesn't make a v, and then after so much time it makes another v, and after so much time, they don't repeat like a periodic function does here, like sine and cosine. And so the last one is the period. The period just means how long does it take before the pattern repeats itself, right? By default, what's the period of sine and cosine? 2 pi. They repeat themselves after 2 pi. The pattern starts over. The pattern starts over. So when you look at, let me write the parent function up there. So without looking at the notes, if I just look at y equals sine of x. This is the same thing with just more junk in there. What do you guys think? If you had to guess what A, B, C, or D affect, which ones do you feel good about? The plus D. What's plus D do? Which one of these transformations would plus D affect? Vertical shift. When we add or subtract something on the outside, it shifts the graph up or down. That's the same thing it does here. Whatever the D value is, that is your vertical shift. Okay? So if it's plus 3, we're shifting the graph up 3. One of the new vocabulary words that we can talk about is the midline. So the midline originally is the x-axis, because that's the one that it touches twice, right? Before it goes back through. It starts at the midline, sine does. Sine starts at the midline, goes up, down, down, back up to the midline. Well, if we shift the graph up 3, the midline goes up 3 with it, right? The point that's in the middle. And so I never did a lot of work calling stuff the midline until we get to my open math last year. And that's kind of a thing that they stress. I think it's good, just not something I use a lot, because it's not normal, not natural. I was not taught that way, I guess I should say. What other things do you feel good about here? What's the A do? A is multiplying on the outside. Outside affects the y's. So when we multiply by the y's, we're normally doing a vertical stretch or compression. So here the A represents the amplitude. Okay? The A can be positive or negative, but amplitude is always positive. Can we make that note somewhere? Amplitude is always positive. So if this number out front was a negative 5, what's my amplitude? 5. What's the negative do? If I had negative 5 times the absolute value of x, think about this graph. What does the 5 do? The 5 stretches the graph. What does the negative do? Negative doesn't compress. Compression would be like this.
It flips it.
Flips it. This is a reflection. This makes the graph open the other direction. Same thing here. This negative will flip sine. So it doesn't start going up, it starts going down. But the amplitude is still 5. Amplitude is always positive. Always positive. The negative is a reflection. Okay? Then looking inside of here, we've got phase shift and period that we haven't dealt with yet. So the phase shift is what used to be a horizontal shift. Which of these reminds you more of a horizontal shift? What moves the graph left or right? This one, the C over B, right? So, just as a quick reminder, if I had the absolute value of x plus 3, what does this do to the graph? Left 3. It does the opposite of what it looks like. Same thing here, that's why they have a negative here. So if this was sine of x plus pi over 2, this is moving the graph left pi over 2. Okay? So C over B is the phase shift. That's what that's called. It used to be horizontal shift, but now it is the phase shift. Then the last one people get the most confused about. Okay, so here's the way I explain it. I'm not telling you I do a great job with this. So obviously I don't, because my students get confused every time. B affects the period. B is not the period. I want to write that somewhere. That's a great note. B affects the period. B is not the period. What is the period of sine and cosine? 2 pi. It's 2 pi. I don't even want to talk about it because it just gets confusing. Here's how that works. If I had sine of 2x, you see how this is not a phase shift. I'm not adding or subtracting. So it's not left or right. So this is being multiplied by the x, which means I'm affecting the period. Here's what we do to figure out what the new period is. The period is 2 pi over b. 2 pi over b. And what you'll probably hear me say is it's the default period over b. And by default, sine and cosine have a period of 2 pi. So in this case, the b value is 2. So what would be 2 pi divided by 2? It would just be pi. And so this function has a period of pi. Which means what happened? The period used to be 2 pi. Which means I was here, I went up, I went down, I went down, I went up. That was one full cycle. That's a period of 2 pi. If the period is now pi, what's happening? It has to complete a full cycle between here and here. Because the period is how long it takes to complete a cycle. So now the graph would go here, and then here, and then here, here. So what's essentially happened to get from the black graph to the brown graph? It's very similar to a horizontal compression, right? Horizontal compression. And it does the opposite from what you think. This is a 2 inside. 2 you might think is a stretch. It's not. Remember, inside does the opposite. It's a compression. So I'm taking that sine wave and I'm compressing it. So it completes its cycles twice as fast. That's what the 2. Okay? Questions about any of that? Everything I just said about sine applies to cosine. No difference. All right? Nothing changes between sine and cosine with anything I've talked about here. The only thing that's different is where they start. All right? That's it. look at these two examples. They are on page 2, not at the very bottom, but close. Page 2 of your guided notes. Y'all see them? So we're just practicing finding the period. So let's start with this one. What's the period of sine of pi over 6 times x? So how do we find the period? We take the default period and we divide it by whatever's being multiplied by that x. So what's the default period of sine? 2 pi. Divided by b. b is the number that multiplies the x. So 2 pi over 6. Can you guys simplify that real quick? I couldn't. This used to confuse the crap out of me. Okay, this is why I used to make this like, okay, this is 2 pi over 1 divided by pi over 6, which means I need to multiply by the reciprocal. Have I explained all this stuff to you guys before? Probably at some point. Fraction divided by fraction, not keep, change, flip. Don't you say that word. Multiply by the reciprocal. Now what happens when I multiply these? Well, I can cross-reduce these. There's a pi on top and bottom. They're gone. 2 times 6 is 12 over 1. So the period is just good old number 12. So when something like this happens, right, it's still in radians, remember, but sometimes we have those jacked up radians. Like, remember what 1 radian is? On my explanation of what radians are? And then like 3 radians almost got me halfway around the circle, but I need a little bit more than 3, which was pi radians is what I needed. Well, so I'm no longer talking about it in terms of pi. I'm just back to good old regular numbers, which means if I had to graph something like this, my x's would not be with pi's anymore. They would just be like your normal x's. So I would have something like 3, 6, 9, and 12. And that's how long it would take to complete one full cycle, because the period is now just regular number 12. That's okay. That's a lot. How about the next one? The next one, we are looking at cosine of x over 3. Well, that looks a little different. Could I write this so it looks like b times x? X over 3 is the same thing as 1/3 times x. Do you buy that? It's the same thing. So now my b value is 1/3. So to find the period of this function, I would do the default 2 pi divided by 1/3. Or again, this is 2 pi over 1 divided by 2 pi over 1 times 3 over 1. So the period is now 6 pi. So this one keeps the pi in it, right? Where the other one, the pi completely canceled out. Oh gosh, there's no good stopping point. Let's just. I don't know. I'm trying to see where a good stopping point is. There's one, so I'm just gonna keep going. Huh? Now? No, this is not a good stone. Huh?
You're hearing things.
Oh, am I?
Your skin is glowing today.
Hmm?
Your skin is glowing.
Wow. Thanks. Okay, this is ugly, right? This one here is your default sine wave. This is sine of x. What's happening to go from here to here to here to here? We are changing the amplitude, right? I'm not changing how long it takes to complete a cycle, right? To go from here back to here. Sorry, this is too right here. From here to here is one cycle. But if I go with the highest one, how long does it take me to complete one cycle? It's the same amount of time, right? Not affecting the period. It's still completing its cycle in the same amount of time. But it's changing the highs and the lows. The highs are getting higher, the lows are getting lower. That's amplitude change, or a vertical stretch. What they say here, if A is negative, the amplitude is the absolute value of A. Which again, that's what I told you, the A is always positive, right? Never negative. The negative tells us to do the reflection. It's going to go the opposite direction. That's good they had that note there. That they had here. So like the next wave up, this is what 2 times sine of x would look like. This is what 3 times sine of x would look like. Because it gets all the way up to 3, all the way down to negative 3. 4 sine of x starts all the way up, or gets all the way up to 4, goes all the way down to negative 4. The highs are getting higher, the lows are getting lower as you multiply by those numbers. Okay. I don't know if I love the layout. It just seems like a lot of junk. You guys follow the different waves? What's the first question? What is the amplitude of the sinusoidal function f of x equals negative 4 sine of x? So first question, negative 4 times sine of x, what would be its amplitude? Where are you getting 8 from? You're looking at this one. No, right here. You'll see this one? Sorry. I follow. I'm looking at that one above it. So the amplitude of negative 4 times sine of x is 4. Amplitude is 4. Is this function stretched or compressed? What was the amplitude originally? If before any transformations occur. The amplitude of sine and cosine is 1. It goes between 1 and negative 1. Now the amplitude is 4. So is that stretched or compressed? Stretched, right? It's a stretched graph. Stretched. So again, if this is what a sine wave looks like, if this was sine of x, then this would be what 4 sine of x looks like. The highs get higher, the lows get lower. Stretched. Now let's look at the one beside it. What would be the amplitude of 1/2, or is that 1/3? 1/3. 1/2. What's the amplitude of 1/2 times sine of x? Amplitude would be 1/2. What's the normal amplitude? It's normally 1. So is this stretched or compressed? It's a compression. When it's less than 1, when the absolute value is less than 1, right? If it's a fraction, a half, a third, a fourth, you're compressing the graph. If it's 2, 3, 4, you're stretching the graph. Remember, the negative does something else. It doesn't stretch or compress. So, if this is what sine of x looks like, then 1/2 sine of x would look like this. It's compressed. The highs aren't as high. The lows aren't as low. Right? Compressed. Like a trash compactor. Right?
How come that one stays positive? The amplitude.
Amplitude is always positive. Always. Can't have a negative amplitude. The negative is a reflection. Right? I didn't do a good job here. I forgot this was negative. So because this is -4, if I graphed it, it really should look like the purple one. Right? This should be -4 sine of x. The negative reflects it. So instead of going up initially, it goes down initially. Then when it goes down, this one goes up. Right?
Is that how we should graph it though? Like, should we graph it like the purple or should we graph it like the
Yeah, if you had to graph -4 sine of x, it would be the purple one. You see, I did a bad job. I talked about sine of x and 4 sine of x. I never went to negative. I forgot the reflection. So the purple one is the final graph. Oh my gosh, don't do that. Let's do the bottom ones. If I looked at y equals -8 times the cosine of 1/3 x. So now I'm combining these transformations, right? I have some of both. These are the last ones we'll do. What's the amplitude of this? 8. 8. Everybody's good with that? What's the period of this? 2 pi over 1/3, which is 6 pi. You may go through the process of getting 6 pi from that? Is everybody okay with that? Go through it. Let's go through it. I've got 2 pi over 1 divided by 1/3. So I need to multiply by the reciprocal. So if I multiply by 3 over 1, 2 pi times 3 is 6 pi. On the second one, what's the amplitude of 2 sine of 9x? 2. What's the period? 2 pi over 9. So again, just thinking about it here, this 1/3 changed the period to 6 pi. This means it's going to take longer to complete one cycle. It normally takes 2 pi and now it takes 6 pi. Here, multiplying by 9 on the inside, it normally takes 2 pi to complete a full cycle. Now the whole cycle's done in 2 pi over 9. It's speeding up the cycle, where this is slowing down.
It stays similar to the sine.
I mean, it's going to grow, but this unit is very heavily in all of this. We're going to put all 4 of them in a second. Last thing we looked at yesterday, we were looking at amplitude changes and period changes. Amplitude changes and period changes, those are both being multiplied in some way, right? The A multiplied on the outside affects the amplitude, which is like a vertical stretch or compression. The B on the inside affects the period. Remember, B is not your new period. In order to find the new period, we take 2 pi, or the default period, and divide it by B. Now, today we're going to be looking at the last two, which would be a phase shift and a vertical shift. So phase shift is like a horizontal shift, left and right. And remember, on the inside, it does the opposite from what it looks like it should do. That's why it has a negative there. The one thing, just me calling it out right here, as I look at these two examples you're fixing to do, look at this example and this example. What do you notice is different?
The B's inside. One of them has it where the B's factored out.
Right. So here, the B is factored out in front of the X minus the phase shift. right? Where here, this one is not factored out. So, what's important for me to tell you is, on this one, I cannot find the phase shift until I factor the 5 out. Okay? So, this one, the phase shift is not negative pi plus 7. This is the form we like to see. This one is better for us. So, as I'm looking at this, what would be the amplitude? Amplitude of that example? 2. Remember, it's the number being multiplied out front. The absolute value of it, right? Never the negative. Right, next, what would be the period? So how do we find the period? Remember the formula. It's the default, which is 2 pi, over b, which this time is 5. So the period is 2 pi over 5. And then what would be my phase shift? We are going right pi over 3. Therefore, it's a positive pi over 3. Look over this. The next one. What's the amplitude? 1. There is no change to the amplitude, so by default the amplitude is 1. The amplitude does not exist, or 0, right? It has to be a number that's not 0. And so it's going to be 1 here. What would be my period this time? It's not 5. Right. We can do the period before we factor it, but we could factor right now. Either way. Let's go ahead and factor the 5 out. So this has become sine of, factor a 5 out, so this becomes x plus. What happens if I factor a 5 out of pi over 7? A little confusing, right? You're like, I've never done that. But you have. Let me make you factor something else out. If I had 2x plus 6, these are both even. So you can factor a 2 out. What happens if you factor a 2 out from this? You're left with, well, how did you get this? I divided what was there by what I was factoring out by. So guess what you have to do here? You have to divide what was there. Well, what was there is pi over 7. I'm going to divide that by 5. Well, how do we divide by 5? I guess y'all just use a calculator. For me, I don't carry a calculator. So I'm going to multiply by the reciprocal, which leaves me with pi over 35. If you do use your calculator, remember, just leave pi out of it and tack it on at the end. Okay, so you would do 1/7 divided by 5. And you would get 1 over 35, which is pi over 35. Everybody's good? So looking here, what would my period be? 2 pi over 5. So see, I can really still identify the period from this one, right? It doesn't really affect the period. The one it does affect is the phase shift. So now my phase shift would be negative pi over 35. I mean, I'm going left pi over 35. Questions on that one? So, horizontal shift is the plus D on the outside. That's going to shift the graph up or down. If it's positive, we go up. If it's negative, we go down. One thing that this My Open Math does, your Canvas assignments, is it talks about midlines, which is not something I'd ever seen before I started teaching the My Open Math curriculum, but I do like that idea. So what they're saying about midline is, normally, this is my midline, right? It's the center of the sine wave and the cosine wave, right through the middle. So if I shift the graph, it looks like here, they shifted the graph up 2. So the midline also moves up 2, right? So we can kind of tell what the shift is by looking at the midline. For me personally, when I used to shift these, I used to shift them from the valley, which was at -1. If I go up 2, now I'm at 1. And the peak used to be at 1, now it's at 3. I never really thought about moving the midline, but they really emphasize that. So, I mean, it all works the same. So looking at this equation, is this in the form that I like for it to be in? Yes. What do I mean by that? The B value here is already factored out. That's the main thing you need to look at. So this is in a good form, so I can go ahead and identify all of these things. What would be the amplitude? 7. That means I'm stretching the graph by 7. The period would be, it's not 6, it's 2 pi over 6. Remember, B is not the period, B affects the period. 2 pi over 6 is pi over 3, reduced. 2/6 is 1/3. Horizontal shift. So the way that this one is written, I agree. I would say -3. The way this one's written, I think the answer is 3 to the left. Right, so you might just have to be careful how they word that. But you're correct. -3 is the phase shift, which means we're moving 3 to the left. And then where's the midline at? It's up to y equals 5. So you see they've already started that equation for us. They've already got y equals fill in the blank. For us, that would be y equals 5. Questions? So this one I would do, I would have 2 pi divided by 5 pi over 4. So for me, I make that 2 pi over 1 divided by 5 pi over 4. 2 pi over 1 times the reciprocal. Okay, pi's cancel. 2 times 4 is 8. 5, 8/5.
Auto answer.
I just discovered you can do a coin flip.
Oh shoot, what did I do?
Yeah. You can do a coin flip.
That's something I don't want to do. Okay.
No, I already got it.
You can also, it has a random number generator on it.
Yeah, I
too.
know about that. I've done that before.
Sorry, I forgot I've already talked about that.
Oh yeah, that's right below coin toss.
Is it? And just so you know, there are 4 free response questions on the AP exam. One of them is going to be about this. It's guaranteed. So one of the free response questions will be about transformations of a sinusoidal. It's a guarantee. We'll talk more about all that as we start preparing for the test, but right now I'm just wanting to teach you the math.
I don't know if I know if it's gonna happen. 'Cause I don't know.
They still haven't sent me that survey of my money yet. I'm gonna call customer
You
service
better,
today
you better.
to find out what's going on.
Where's my money? Give me my money.
I did a whole test for 3 hours and 15 minutes for money, and they haven't given me money.
Oh yeah, you need to check in.
My mom called Wendy's yesterday after she got home, so they got the order wrong.
What'd they do? That's it?
I don't know why she's just immediate.
But if you want it to be a mix of you.
I normally will, if I'm mad enough, if I get aggravated and I don't want to drive back, I'll start messaging their corporate office, see if they'll give me a refund or give me a credit. That's about all I do.
Dairy Queen, and they gave me the absolute worst thing I've ever done in my life. Me and Ella got yelled, and they would back you up for you.
How'd that go?
Don't go to Dairy Queen because Linda is rude and
Dairy Queen got
milkshake.
Lucas was saying that raw chicken the other day.
And that's why Dairy Queen is ice cream only. Just ice cream only. Oh, yeah. I'll still go get their ice cream. That ice cream's good.
Cookie dough blizzard.
Sonic cheeseburger.
They get a little bit messy.
Sonic, they just started steering. Sonic is good in general.
I need to use orange.
Because I thought the order was there, and I go there, and this and then I see like everybody I think they know. I don't know why I'm so close to
Now it works better.
Like, I was just sitting there, and it's just,
Where you sitting weird like that?
I drove it. What are you talking
but like, I was just.
You haven't talked about how Brady used to sit all the time?
I live
Yes.
sat on him on a lace roll. She sat on my
Yeah.
I drove by
She would. She like
Right.
put her feet up in the.
He was in the sauna after
It's cold.
All right, I could have messed up on some of these, but I think I got them all answered.
It's actually really so bad. You don't even know.
Okay, will you work out the third one?
Because I did.
Yep. Just the period
Still the whole time.
for the third one?
Yeah.
Okay, so the first thing about the third one is it's kind of flip-flopped out of order, right? This is what's normally written first, and then it would be minus 3. So I'm going to rewrite it as cosine of 1/6 x plus pi over 24 minus 3. Now it looks like the order that I'm used to seeing it. And then the next thing I would do if I'm working the whole thing is I'm going to go ahead and factor this 1/6 out. Right, I need to pull 1/6 out of the parentheses. So now then I need to divide. What is pi over 24 divided by 1/6? Well, dividing by 1/6 is multiplying by 6. I can cross reduce, and this becomes pi over 4.
So, does it matter which one you flip?
Yes.
Because I flipped the other one.
It does.
So I didn't get it.
That's correct.
I
You got
flipped it,
one-
I got 4
you-
over pi.
Yeah, you got the other.
Yeah.
You always flip the second one.
Wait, okay, I just put it 1 over 6 first. Like I just wrote that first.
Yeah, and that'll make you mess it up too.
It came first, cause it was like.
No,
first.
it's always this one divided by this one. That's why if you look back, I don't like using those letters. Like if you look back at how they originally explained it to you, they told you the phase shift was negative C over B. Because it's always this value divided by the B value. Not that I like it.
How did you get 12 pi for the period?
Okay? Let me,
I missed both of the periods on the last two.
2 pi times 6.
it is 2 pi times 6. It should be 2 pi divided by 1/6. And so this becomes 2 pi over 1.
Okay, I think it's because I divided both of the periods by the phase. Yeah.
Now we take our default period, which for sine and cosine is 2 pi, and divide it by the b value. So multiply by the reciprocal, which is,
Oh, I didn't know how to find a period until like 5 days ago.
yeah, she wasn't here yesterday. Give her a break. She could watch the video I posted, except I didn't post it. But you know,
I would have done the same thing.
I'm extending because I didn't finish teaching 2.1, so I'm posting it today. I probably screwed up.
She learned more in one day than I learned in a month.
Higher. No. Thank you.
And then, on the equation in the midline, on the 3, is that a negative 3?
No.
So it is a positive 3.
No, it's negative, sorry.
Okay. I had negative.
I can't even read it, it's negative 3.
Okay.
Then I look back to double check, I'm like, ooh, it should be negative.
Okay, because I put -3, but then I looked and I didn't.
Yeah, see, look how that one's longer. That's because that's a negative.
Yeah.
Why equals -3? It really is in there.
Okay.
I can go back. I can show you. I can show you me writing it. Here, let's watch me write it. Table, and I'm sure there's probably a really good way to fill this table out. And I probably should have watched the people at Northeast teach it so I could see what they wanted me to do with this table. But to me, this just all looks like nonsense. So I'm ignoring that part. Okay, I don't know what we're going for. But what they're wanting me to teach you how to do is how to transform my 5 critical points, my 5 key points. So we looked at the 5 critical points for sine and cosine yesterday. How do I know if I need the critical points for sine or cosine? Well, it's cosine. So because this is a cosine graph, I'm going to start with the 5 critical points for cosine. Do you have them memorized? Does cosine start at the origin or at 1? So 0, 1. So if I start at the top, where's the next one? Has to come down to 0. Then we have to keep going down to -1, back up to 0, and then back up to 1. Those are my 5 critical points. Again, you can form them all like this is the only one I know. Really. I know 0, 1 is cosine. And then I just make it go from there, right? This is every axis. And then down, down, up, up. Because I've got to finish a cycle. It never goes above 1, never goes below -1. So those are the points I started with. If my equation was just cosine of x. Unfortunately, my equation is not just cosine of x. I've got other garbage going on. So let's identify what we need to do with each of these values. So the -4 affects the amplitude. So that means I need to multiply my y's by -4. Right? Because I'm stretching by 4. Then the negative is reflecting the graph. So I can do that at the same time. I can stretch it by 4, multiply by negative to reflect it. Is there anything else I'm going to have to multiply by? Yeah, this 2 is multiplying. The 2 affects the x's, right? So what did I do with that 2 in order to find the period? I take 2 pi and I divide it by b. Well, I know this needs to be the end, right? This is the end. So if I take 2 pi and divide it by 2, I get the correct period, which is pi. So the other thing I need to do, I need to divide x's by 2. You see how I reason my way through that? I know this is the end of the cycle, so this needs to be the period. The period used to be 2 pi. Well, I divide it by 2, turn it into pi. And I'm going to do the same thing with all the x's. Okay? Then what else happens? What are my other transformations? I need to shift the graph right pi. So going right pi would mean I need to add pi to the x's, right? Because right is x. And then what's the +1 doing? Add 1 to my y's. And once I do all of that, I can find my new 5 points. Like, these are the 5 points where they started, and this is going to be where they end up. Okay? Notice, order of operations matters. So you always have to do multiplication first, multiply and divide, which is the amplitude and the period change. And then you do the addition and subtraction second, which would be the phase shift and the vertical shift. So here we go. Let's multiply all the y's by -4 first, because that seems like that would be easy. What's 1 times negative 4? Negative 4. What's 0 times negative 4? 0. What's negative 1 times negative 4? 4. What's 0 times negative 4? 0. What's 1 times negative 4? Negative 4. You see, I've multiplied all of the y's by negative 4. Let's go with that. That's stretched and reflected, all in one. Now, divide the x's by 2. So, what's 0 divided by 2? I got 0 piece of pizza. I'm going to divide them evenly among 2 people. How many slices of pizza does everyone get? 0. 0 divided by 2 is 0. What's pi over 2 divided by 2? Pi over 4. Half of half. What's half of pi? What's half of 3 pi over 2? 3 pi over 4. What's half of 2 pi? Now, if you do this correctly, on this step, whatever this x value is should match whatever the period is. Every time. What's the period? 2 pi over 2, which is pi. That matches it. Okay? That will always match the period on this step before I do the phase shift or the vertical shift. Now then, from here, I need to add 1 to my y's. So negative 4 plus 1. Negative 3. 0 plus 1. 1. 4 plus 1. 0 plus 1. Negative 4 plus 1. That's a negative 3 if we have more controversy. I didn't draw the world's worst 3. Okay, it's a negative. I mean, that is striking how different those are. Like somebody would think that they forged my signature on that one. That does not look like my numbers. Okay, and same to the x's. Now I need to add pi to all of my x's. So what's 0 plus pi? Pi over 4 plus pi. How did we get that? How do we get that?
So you just add 1 to 4.
This is 1/4. What's another way to say pi? It could be 4/4. So what's 1/4 plus 4/4 pi?
5/4 pi.
5/4 pi. And if I've got a whole pi, I've got 4/4 of pi. 4/4 pi plus 1/4 pi is 5/4 pi. So here, this is pi over 2 plus pi, 3 pi over 2. Right, that becomes 2 pi over 2. So 1 pi over 2 plus 2 pi over 2 is 3 pi over 2. 7 pi over 4. I'm just assuming if Dawson's got it, y'all got it. Is that a good assumption? And then pi plus pi is 2 pi. We good with that? These are my critical points. I maybe should have wrote those one over because I don't want to copy them all again. But this, if I had to graph this, I would go graph these points. And that gives me one full cycle, and then I can continue the pattern. Now, one thing I will say is, if you have to graph this by hand, you can't start right here and say this is the point pi negative 3. Because that's the origin, right? So you've got to make sure every one of your tick marks is equally spaced. That's very important. So in this one, they would all be by force. Okay, so here, they're graphed, and they want me to identify what the points are, and then identify some of the transformations that have occurred. I think this is so easy, though, because it gives you the equation right here. So whatever. So let's come up with these points first. Where are the coordinates of point A? 0, 4. B, pi 2.
C, 2 pi 4. D, 3 pi 6. And E, 4 pi 4. What's the amplitude? And that's easy to spot because it's here, right? If it was not, could you identify the amplitude just from this graph? If the midline's right there, can you tell me what the amplitude is? Well, from the midline, we go up 2, we go down 2. That makes the amplitude 2. Okay? What's the equation of that midline? Y equals 4, which means I have a plus 4 as my D. Again, that's there. What would be the B value here? It's not 2. It's 1/2. I can rewrite this as sine of 1/2 times x. Right? X over 2 is the same thing as 1/2 times x. Which means my B value is 1/2. The period then would be 2 pi over 1/2, which is 4 pi. And again, we could tell that just from looking at this if we needed to. Right? How long does it take to complete one cycle? Well, we start at 0, we end at 4 pi. That means that the period, the amount of time it takes to finish one cycle, is 4 pi. And the phase shift. I ain't one. 0. It's probably 0 is what you need to write. But I'm just sticking it to the man and saying ain't. So. So, with my class yesterday, I tried to do this one. I made them do this one without knowing the equation. And it's possible. Like, if you didn't know this up top, you should be able to identify every one of those things from the graph. Alright? But you can't do it with this one. Alright? Then I tried to do it with this one, and it just turned into a disaster. Because the period is... You're right. And so then I tried to say, well, it's halfway. And then like, it's not. So we did them halfways, and then Brandon said, that's not going to work. And I said, oh yeah, it looks like it looks like halfway is here. So this is halfway between the halfway. And I was wrong too. And I said, well, you know what, Brandon? No, I didn't say it to Brandon. So obviously on this one, you're going to have to use the equation. So looking there at it, what's the amplitude? 3. Could you identify the amplitude without the equation? Yes, midline is here. I go up 3, I go down 3. Equation of the midline. We could identify that without the equation. What's my B value? I can't do that without the equation. Okay. I thought we could. We can't. It's 3. Which means what is my period? 2 pi over 3. Phase shift ain't 1. 0. And I guess I need to go through these points now. So finding the points, I know what this point is. 0, -1. I know what this point is. E. What's the x coordinate? How do you know? That's the period. That's one full cycle. I went from the bottom, from the valley to the next valley. That's a difference of 2 pi over 3. -1. Now, any thoughts on identifying the other points? Now that we know that. Nope, none? It is possible. It is.
it was not possible without not knowing the B value. But now that I do know the B value, it is possible. C, how can I find C?
It's in the middle of 2 pi over 3, 0.
Yeah, it's halfway between 0 and 2 pi over 3. So what would be the halfway point? Well, this is 0, and this is 2/3. The halfway point would be 1/3. 1/3, or pi over 3. So the x coordinate for C would be pi over 3. My y coordinate is 5. Let's find the B value. Well, if this is pi over 3 to get to here. B is halfway between 0 and pi over 3, which is 1/6, which is pi over 6. So this would be pi over 6. Y coordinate is 2. So if we're increasing by a sixth, this would be 0, 1/6, 2/6, 3/6, otherwise known as a half. Right? And we can see, look, that one lines up exactly on pi over 2. All right, so we've done all this in radians. Well, we can do it in degrees. Why? I don't know, just because we can. I wish we didn't, but we can. So let's graph this. Yeah, so. I didn't get this far in my last class, so I'm trying to debate on how I want to teach this.
We could skip it.
You could? Okay, just skip it. Here's what I would do. Here's what I'm going to do. I'm going to teach it using critical points. What are the critical points of cosine by default? 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, 2 pi, 1. We good with that? You sound just like me. Thanks so much. Now what's different here? We're not doing radians. So can I change these from radians to degrees? So let's just go ahead and do that. 0, 1, 90, 0, 180, negative 1, 270, 0, 361. Those are the default ones, right? Nothing's happened to them. I just changed from radians to degrees. This is not my default cosine wave, though. What's different about this cosine wave? It's got a negative 2 in front of it, which means the amplitude is 2, and it's been reflected. So I can multiply the y's by negative 2, which means my coordinates should be at 0, negative 2, 90, 0, 180, 2, 270, 0, 360, negative 2. Everybody's okay with that? I multiplied all my y's by negative 2. So let's graph these points. I've got 0, negative 2. That's great. Next is 90, 0. I can't go that far, right? Huh? Just imagine them, if you want to.
Oh, wait, you can just go back the other way.
You can't just go the other way. Because I know what about this point? This is the valley. This is as low as it gets. So if I start working in the other direction, when should it get back to the x-axis? At negative 90. We're back at the midline. And then at negative 180, we're up to the peak, which is at 2. It'll be back to the midline at negative 270. And that's all of that graph that I can see. And so at 15, we're starting to head back up. And that's all of the way that we get on that interval. Yeah. Good point. Okay, here, this one. Sine wave. Quickly. What are the critical points for sine? 0, 0. Pi over 2, 1. Pi, 0. 3 pi over 2, negative 1. 2 pi, 0. And what's happened to those critical points in this equation? They've been reflected and down 1. So I need to multiply all the y's by negative 1 to reflect it. And then I need to go down 1. So this becomes 0, 0, pi over 2, negative 1, pi 0, 3 pi over 2, positive 1, 2 pi 0. And now we're going down 1. Shift over. So down 1, this becomes 0, negative 1. Pi over 2, negative 2. Pi, negative 1. 3 pi over 2, 0. 2 pi, negative 1. So 0, negative 1. Pi over 2, negative 2. Pi, negative 1. 3 pi over 2, 0. 2 pi, just off screen. We're back to negative 1. So it would be here, to here, to there, to there. Oh, I did a bad job finishing my graph, right? This is the midline, so it should continue up from there, right? Because here's my midline. Up to 0. It's not quite at 0 yet. It's just, you get the idea. It's a rough sketch. It's not an exact. Okay, let's fly through the last one. We got a minute and a half. What's the amplitude? 4. Where's the midline? Y equals 1. What's the period? It would be 2 pi over b. What's my b value? 1/4. So 2 pi over 1/4 is 8 pi. Phase shift, 0. Domain, negative infinity to infinity, always. Can you guys do the range without us graphing it? Range would be the y's. What's the normal range? It's normally negative 1 to 1. The amplitude by 4, negative 4 to 4, up 1.
Negative 3 to 5.
Negative 3 to 5. Right? Follow the progression, and those would be in brackets. Well, we'll graph it. We'll graph it. I'm going to come back, I guess. Or graph it for homework. There we go. Graph it for homework. Thanks. Critical points should be at, I'm just doing the default ones. We're at sine. 0, 0. Pi over 2, 1. Pi, 0. 3 pi over 2, negative 1. 2 pi, 0. I need to multiply the y's by 4, which is going to put this at 0, 4, 0, negative 4, and 0. So that's the stretch by 4 that happens here. And then like we talked about up here, the b value is 1/4, which means I need to divide all of my x's by 1/4. Well, dividing by 1/4 is the same thing as multiplying by 4. Same thing. So 0 times 4 is 0. Pi over 2 times 4 is 2 pi. Pi times 4 is 4 pi. 3 pi over 2 times 4 would be 6 pi. And 2 pi times 4 is 8 pi. When you get to this step, you see how your x value matches your period, the last one. That should always happen on this step before you do the phase shift. And now then, the only transformation I've not done is the adding 1 to my y's. So if I add 1 to all of my y's, I'm at 0, 1. I'm at 2 pi 5. I'm at 4 pi 1. I'm at 6 pi negative 3. And 8 pi 1. Then I can graph 0, 1. 2 pi 5. 4 pi 1. 6 pi is off the graph. So if I had to extend this, it would be at negative 2 pi, right? I should be all the way down to negative 3. Right, because I'm hitting those peaks and valleys or the midline every 2 pi. So the next 2 pi over, I should be down in the valley. Yeah, that's going to be 9 pi over 2. It just ran out of space. And